fourth Manchester Meetup. I just wanted to tell you that over 100 people have registered this evening, and it's good to see so many logged in this early. My name's Terry Lockwood. I'm a director at Rixton EPAM, and will be the lead this evening, assisted by Yeva. In fact, Yeva's doing all the hard work, of course. This MuleSoft Meetup aims to educate, challenge, and provide thought-provoking talks on MuleSoft's API-led approach to integration and how it's being used by organizations to transform their business. The goal of this event is really straightforward. It's to build a vibrant and self-sustaining Mule developer community in the region, foster engagement, and this is the really important point for ongoing meetups: engagement between ourselves, and evangelize and promote our successes based on real-world MuleSoft delivery experiences. I'm pleased to say that we've got three key professionals tonight. We've got Bobby James from the Cooperative Bank, who will talk about the concepts of layers and the design mistakes that can be made if one follows it too rigorously. We've got Francis Edwards. Good to see you again, Francis. I know you've presented a couple of times before, but always welcome to come back. From Saint-Gobain Building Distribution, Francis will show some practical examples of how the decomposition of layers can satisfy such requirements as support, operations, microservices, and even enable easier iteration of improvements to the overall workflow. And finally, we've got Justin Saliba from Rixton EPAM, who's going to walk us through the practical adoption of a unified integration and API platform that enables Air Malta's digital transformation. So, as we can't be totally interactive tonight and face-to-face, please ask your questions in chat, and note that we're going to pick randomly towards the end of the evening 3 people that have put questions forward, and those 3 people will win a training voucher from MuleSoft. So I'm going to basically gather some questions and ask them. The only rules really is that each of the speakers are going to be speaking between 20-25 minutes, and we'll have 5 or 10 minute questions, and we'll try and keep to the time scales we've got. So look, have a great evening ahead, everybody, and I hope you learned something, and I hope it gets everyone thinking about their own situations. And for the sake of progress, we'll just choose questions as I said, towards the end of each session, not to interrupt the flow of everybody. So many thanks. Great to see you all, and over to Bobby.
Yeah, can you hear me then? I presume you can hear me okay? Yeah, can you hear me? Yeah, yep. And I've shared my screen. Oh, it's finally popped up. Brilliant. Right, so just to echo that last point, it sounds like you need to dash and get a comb as quick between now and the next 2 hours. So this presentation came off the back of where I was working, where I was asked to give a kind of a presentation about my experiences with MuleSoft and API design and so on. And specifically, the question is what's your experience with layers? And it didn't take me long to conclude that it just can cause all sorts of problems and things like this. And so this is a kind of the presentation around what I did to present to colleagues about my conclusions, shall we say. So if you bear with me and just humour me whilst I go through some of these. So I've also sort of subtitled it a presentation of apologies, because when I was walking through this, I kept thinking I need to apologise for this because it's a bit things. So so some of the other presentations I've seen, they often go very detailed into sort of the of MuleSoft and the capabilities of Studio and so on and so forth. This is very much talking from an architectural perspective and potentially new to the product architecture perspective as well. So apologies, I feel I'm going to be preaching to the converted here as well. And on top of that as well, when I assess my previous experience, I've probably only been working heavily with MuleSoft for about a year or so, and I know there's going to be people who have been working here for sort of years, and so therefore again, potentially I'm talking down to people when they potentially know it better than me, but then I would argue that potentially they should be up here presenting their wealth of experience and all that kind of good stuff. So hey ho, it goes with things. The other sort of thing I will say is I may end up using some colourful language at some point, by accident, deliberately, well, hopefully more by accident, but I've got caught out on Zoom calls before now where little ears are listening in. So just to make you aware, really, in case anything happens. And if so, I apologise now. And if little ears are listening in, it's not clever to swear, but it's often fun anyway. So moving on to the slide. Moving on. Not moving. There we go. So bit of introduction to myself, because I think it's pertinent to why this came about. I'm currently the MuleSoft solution architect of the Cooperative Bank. I joined about 17 months ago to join a growing collective of solution architecture community to provide sort of durable documentation and sort of designs within the bank. And very quickly, I moved on to a project, which the project basically was changing the way they onboard customers. So you can use sort of, Gartner top applications like Salesforce for doing the data collection and workflow, and MuleSoft for the integration of this with third parties and bank applications and all that kind of good stuff. That morphed into a kind of MuleSoft overall arching within the Integration Center of Excellence. So because the bank was looking for an API first integration principles, they were looking to potentially run it out across a number of applications across the bank. Add to that as well, you've got, add to that, you had a number of architects who were kind of new to the API concept of integration. And that led to, as I said earlier, can you do this presentation to the bank, which is where it was. Previous to the Cooperative Bank, I was at Barclays, which is where I kind of really started touching MuleSoft from a practical thing. Whilst Barclays didn't use the full MuleSoft solution, they did use sort of RAML for API design and Exchange as a kind of a central location point for searching APIs. Again, due to whilst Barclays had various pots had a lot of detailed MuleSoft experience, I was pretty much in a transaction cycle that was fairly sort of new to it at the time, which is led to me when I did go to the bank, people thought I was an expert in it, which again, not necessarily so, but anyway. I mentioned I've got a MuleSoft certified application architect. One of the things that came off the back of Barclays was getting the free course, which then led to a voucher, which then led to passing exams and to get the developer and the architect certifications under my belt. Previous to that, I've probably done about 25 years in IT sort of design, probably about 10 to 13 in sort of solution architecture area, things like that. But I was a developer originally, which is another reason why I like the development side of these sort of presentations, because that's where I often go back to. I'm probably a very poor developer now these days because I just don't do it enough. But there's always part of me that's a developer really in a kind of solution architecture cloak really. I've put on my LinkedIn profile, mainly because if you want to read more about that, it's probably the easiest way to do it. Now, I have copied this from a template that says, give it a show of hands if you're new in this meetup. Given the nature of it, I will turn around and suggest just put it in the chat, really. And apologies, I've just copied it from the template and didn't really think too much about whether I need it or not. Right, hang on. I'll do this. That's moving on. Right, so again, I was looking at this and thinking, am I really that sort of brazen to put in for a slide up MuleSoft Meetup group what the definition of an API is? And again, it comes back to how do you start this off? How do you introduce it? And to me, the key elements of this is that even MuleSoft in their training admit the term API is used for a number of different things, for a number of different sort of parts of the things. And I found that commonly used when the places that I've worked. So people use the application to mean the API and therefore assume it's only ever got one endpoint and all sorts of problems like that. In essence, really, it is the endpoint. In essence, you are implementing a layer of abstraction from your application, really, and that's kind of the key thing. And reading through some of the background material for this and preparing it, the layer abstraction is something I think it's key really to things like that. It also mentions about being restless and stateful services. Whilst not sort of written in stone, it should be that way. It's just best practice and what you would want to do. Arguably, if you're having a stateful API, you're creating an integration engine. And where the boundary is, I'm never quite sure, but I remember someone throwing that in a conversation to me one time about that. So anyway, so the next couple of slides kind of show, well, they kind of give the integration nature, the layering nature of APIs. And whilst I've probably gotten back to front, I do like this sort of application network grid because it kind of shows how APIs will evolve. So in the sense that you've got a series of applications, you put an abstract layer to it for another application to potentially call data, potentially it's serving information up to customers or whatever. But it shows that the idea, you kind of a series of dots around the place that acts as an interface or an integration to go to other places, to potentially go to other sort of APIs in order to get information and pull it all together as a kind of total service. So that's the kind of grid thing, and I kind of like that as a way of explaining it, because you could see, if you've seen the diagrams, you see how it kind of grows out as people have more APIs to have more functionality across the estate. The next slide is the layer slide. So if you Google layers, and I've done this a few times in order to find this, because it's the easiest way to find this slide. It's a common slide that's shown up and presented to the screens. It expertly explains what your experience, your process, and your system APIs are, the high-level principles of it, and how it works, and all this sort of, and gives the idea that you've got two separate consumers of that. Albeit it's a mobile phone and an online banking account. It's an online banking sort of so a web screen. That's what I mean to say. So, and I was on a call the other week where someone says, I like this slide because it explains what you're trying to do, and it kind of just summarized the fact that this is why I kind of slide a bit, because it's taken on as is and applied to different situations. And it's not necessarily applicable because the context of it is taken out of context, and the context is not necessarily explained totally. So the next slide is, ideally, if I had super duper slide skills, I'd have these flying across the screen when I touch the button and things like that. But the diagram itself is very much an application architecture diagram. It's showing interconnection between applications and how they kind of fit all together in a grid. It's not kind of like an infrastructure diagram, because you'd have much more networking on there to show that's what's happening. It's not showing some sort of business flow of events. And again, I think some of the things that I've seen done applied wrongly, again, potentially show that's what's been what people have interpreted it as and then applied it as. So some of the things I've heard and kind of disagree with, really, the principle that every layer should be used. So I remember in one place they said they consider an anti-pattern if you didn't use every layer. Right, and I'm sure basically they implemented a load of pass-through process layers that did nothing other than add an extra 50% to the cost of and that's a certain amount of latency to the messaging. If there's no functionality in the process, I'm very much thinking of take it out and that sort of stuff. There's good design reasons to do that from an application growability, functionality, and stuff like that. But if you go from this is why I say I take a more sort of solution approach to it and a more enterprise approach when you're taking cost out. These things can be built up as it goes along, because there's always the principle of versioning on the API, the APIs to kind of move on to the next level. The other thing about this diagram, as I said, it shows you've got a mobile phone and a web things. It's it's an unknown user. You need to validate that user before you come in. Most of the work I've been involved in when I'm integrating with APIs comes from a known application. So it's another application, as I mentioned earlier, something like Salesforce, calling into MuleSoft to go out to a series of third parties to bring up information to do sort of client assessments and those sort of things, right? And thereby, you've got a different security pattern, a different sort of way. And this diagram doesn't show it, albeit I think I've shown newer versions of it that do have that, to therefore give a kind of fuller appreciation of what it is. So if you've got a known application, you can secure the cat channels so much more easy, so much more things. So it changes the way you would deliver and develop these sort of things. Add to that, I was on a project whereby it was literally, we had two applications and who were an internal data center, so they were not passing on any public networks or anything like that. And placed between the two, more to provide a layer of abstraction from the provider application. And the critical in nature for doing that wasn't necessarily for reasons for implementing an API-led estate. It came about because the nature of the application, it had been customized to hell, and so it was just impossible to kind of upgrade. So as a consequence, they were planning to build a new version of it, in a more supportable way, but they wanted this sort of security security, or if you like, of an abstraction layer to that application before it called in. And so you had that. You really only had one sort of layer because it was all internal. And I'll go into why I saw that worked for me earlier. But I do remember someone coming in and starting asking questions. Where's your experience API? Where's your system API? Even the documentation forced you down a route of defining this level of information, even though really it was a layer of abstraction between two applications within an internal data center, not a proper layered structure, if you see what I mean. Semantics of names. Believe it or not, I once had a discussion from someone along the lines of his logic was the third-party application implemented a RESTful interface. Ergo, that was the system-level API. We're calling it from our data center. Therefore, it must be a process API. And we, literally, we just went to and from what's the name. And I thought, does it really matter? There's a functionality and a channel nature to it. The purpose of the API coming out of our data center is to secure the channel to the endpoint. It's to bring back certain information from the endpoint, bring it back into the bank, allow it to be used by other applications, and service it up in a way that's usable by the other applications in the banks. But again, it's taking this and applying it to a certain amount of understanding and going mad on it and stuff like that. And probably the one thing I found when I was digging into the practicality is the fact that on that, and I can't remember where I read it, but I'm sure at one point I read someone said, with this level of integration, you can now create customers in two places. Well, if you've got multiple cluster applications, you can now create them both at the same time in both places. Now, having looked into the practicalities of doing that in a role and task I was doing, it's the oxymoron for a stateless API because if you look at sort of important to sound clever. Now, if you don't know what it is and you look it up, just bear in mind it's a very mathematical thing. Therefore, as a consequence, it doesn't really give you the principle, the concept totally from an IT perspective. But in summary, I believe it means do an action and repeat the action. The result is the same. So if you think of it from a sort of a point of CRUD activity, if you're reading data and you're reading from multiple sources, if something fails in the middle of that request, you can just repeat the request and you'll eventually get all the information. You'll re-get all the information you want. Similar for if it fails in the middle, you can just re-send the request and you'll just be rewriting the same data over each other for the ones that have already succeeded. Similar for delete. Similar for delete in the sense that if it fails in the middle, you've deleted a customer. If you've done database or calls, you try and re-delete it. It just says sorry, or customer doesn't exist or whatever and things like that. So again, all of those work until you get to create. Now, if it fails in the middle of creating a customer, if you resend the message, you then create a new customer. Now, there's ways and means around that, whereby if you can define your customer very sort of primary key for the customer in good detail, then you've got half a chance of being able to make sure that you won't recreate the customer. But I tend to see it very difficult. I've tend to see people not even attempt to do it because of the difficulties of it, So, for example, you could have two people with the same name at the same address. You could have two people with the same surname, with the same birthday, and so on and so forth. So, as a consequence, it can be difficult to do it. There's ways and means, but unless your organisation has accurately defined, as an accurate data model to define customers, it's going to sort of, it's difficult. Add to that, I remember another place someone said to me, oh, you might create it twice. And he said, you don't want to do that because there's so many systems that hang off the back of customer systems and customer databases that are triggered as a consequence. You'll have so much downstream problems as well. You wouldn't want to do it. So the natural sort of IT solution would be to add some sort of state management in there to understand that you've created a customer in one place, able to do it another, and therefore you need to retry and all this sort of things to avoid, deduplication and all that sort of stuff. And as soon as you do that, you're moving into, if you're doing stateful APIs, as I said earlier, you get to the question, are you now implementing an integration engine? So I can't blame that diagram, because you could argue it's the other people's misinterpretation of it and all this sort of things. But that's, you know, some of the sort of comments I've heard, especially when people are learning about APIs at the beginning. So that's my sort of thoughts of it, really. Well, that's why I went into a rant at people at work. But anyway, that's it. Next two slides, we're trying to go back on the past. Woo, it's the early 2000s, right? When three-tier web architecture was common. Look at the sort of solutions, you can see a similarity to your kind of layering diagram. So you've got your presentation layer, presumably now it's UX because it's experience, business logic layer where you're doing a lot of it, and a data access layer, which is like, you know, system layer accessing the system of record. Again, if you search the web for other things like that, Amazon will probably do it as a two-tier web application, because again, they're treating it more as infrastructure units. Therefore, you'll have your data access and process all on one unit. So again, if this probably should be a three-tier, you know, application type web architecture. But again, it kind of meets naturally. Now, the next integration pattern I pulled from the Enterprise Integration Patterns website that's based on a book, which a similar name, I can't remember, I can't say I've read it in detail. But what I was trying to show with these sort of messaging patterns is, again, you've got a similar layer of abstraction from an application. Most applications you'll buy off the shelf now will have abstracted their integration layer from the main application. So they've already got a kind of, if you like, a system layer, consumer layer, experience layer, and all this sort of stuff. The bottom picture is trying to show that you know, you kind of, if you like, an ETL type thing, which again is another integration, and it kind of matches in the sense that your endpoint, you could argue on this diagram, will be your system API, your routing, your translation, and all that sort of stuff will be your process API. You're doing a certain amount of business logic, and then at the other end you've got an application, and again, it doesn't show it, but it's got the same color. It's an endpoint. So arguably, you could say this does fit into the experience ideal, but most times you will be dealing with applications, you will deal with them a black box. Therefore, your system, arguably, your experience and your system will be within that. And if they're all in the same sort of networking, secure networking, this is why I think, again, you're applying the diagram will be in a situation where you're not playing it sort of, you know, you're not playing it correct, I suppose, is whatever. Or there's ways of misinterpreting it. So I thought it was a bit, you know, petulant to say negative things and then not come with the ideas of what I think you should be thinking about as opposed to layers. So to me, it's functionality. As I mentioned earlier, I think channel API works better when you're talking about consumers and providers, because really that's what you're trying to do. Translation, not necessarily a lot of logic, but clearly securing the channel to and from these places. Layer abstraction, as I've mentioned earlier, if you go back in the, you know, the integration is not new. APIs, you know, the whole principle of it was you're trying a layer of extraction away from your main application to allow that application to do the processing for whatever it's required to do. Security as well. I mean, I've done a lot of stuff. Right? We've sat down and decided you do need, you will want an API that doesn't necessarily do much, but you're securing the nature of the connection. You're securing the data coming from it. You want to make sure it's secure from a, you know, data sort of ripping out and all that sort of stuff. Reuse is pretty much known and all that sort of stuff, albeit it's very difficult to, you know, define reuse because there's always a certain amount of clairvoyancy in that. Microservices-ish. Now, I'm not an expert on microservices, but again, there's an element of it that I think is difficulty in doing it. And an application, similar sort of things, you apply microservices, it tends to say you need a separate deployable application. People have interpreted that you need an API application only has one thing, and you have 1,000,000,001 of them, and therefore you're building a brand new micro application. I'd call it micro applications, not microservices anyway, and things like that. So, but the other thing I've also found, I also think if you try and define what the API is doing, then it kind of should naturally, if you work out what you're trying to do with it, it kind of naturally defines its own layer, I think. So if it's a channel, if it's connecting to a third-party endpoint or an endpoint, it's pretty much accessing, it goes into system APIs, if you see what I mean, anyway. So I think I'm coming up. By the way, if you think I'm looking around, it's got various screens up here and I'm looking at my clock. So I think I'm coming to the end of my time. So just to sum up again, to me, layers, I'd rather look at a level of abstraction and what it's trying to do. the common diagram, I think it needs to be sort of stated more. It is an application architecture diagram with that sort of provision. It's not full solution architecture one, or not the full gamut of that. And I'd say think functionality really for me. And right, I'm going to have a glass of drink because I'm dying. Finished.
Okay, Bobby. You want to take some questions?
Stop search. Yeah, go for it.
Yeah, anybody got some questions out there? Thanks, Bobby, by the way. It's good.
Yeah, no worries. Hopefully it was useful.
You must have covered everything here.
Everyone understood it because they've no questions.
Yeah, which is
Because they've got no
fantastic,
questions.
isn't it? Oh, 1 second, 1 second. Bobby, this is from a gentleman called Peter Hubbard. Do you think that the slide is useful to show to newcomers, or does it give people the wrong idea? What a good question.
I think it's natural to show it to newcomers. I think again, it explains layers brilliantly.
Yeah.
So I don't think you can do it off. I think it's just being, if you've got a good layer of governance within there, again, people can bring their ideas to the table and you can govern the way they go out really. But again, I'd say from what I've seen in the last year, it takes some time. So I'm not saying don't use it, but at the same time, I'm just saying be careful really when applying it. To what degree, as I said, there's those 4 or 5 rules that I kind of try and point people at as well now these days. I don't know if that answers your question. I suppose you can't say yes or no, and I suppose I have to check the chat really. But anyway.
Yeah, thanks. Anybody else? Yes, here's one quick query. How this is from Magesh. How did you solve the issue that you've talked about creating a new user?
Well, the way I solved it was this. I didn't actually have to implement anything. I was just thinking from a high level sort of how it would be done, what it would need to be done. I think to be fair, the way we have been approaching that sort of technique is that if you want your APIs to be stateless, you want your applications to be controlling state, because they're often got a certain amount of workflow nature to them. They've got a certain amount of, these applications often have a database under the back of them. Therefore, they're geared up to store state. If you think about, say, something like an MQ, if you think about one of the reasons why APIs came in, I always think of an MQ solution, right? You had the MQ guarantees delivery because it's got a database on the back of it, or some sort of file storage that tells you, yeah, you're doing it. Yeah, it's going to work on all this sort of things. But it can be an overkill for just simple update messages like, update my phone number and all this kind of things, which is why APIs work, APIs, HTTP, RESTless services, that works better. So, but again, you've got an expensive database underneath your method of connection and all that sort of stuff because of it. So I always think, I suppose the rule I would use is try and make sure the consuming application maintains state, try and make sure the consuming application maintains retries, to try and make the API as light and as quick and as simple as possible, really.
Thanks, Bobby.
Hopefully that answers that. Go on.
Anybody? Any more questions? Or there's one more coming through, I think. No, that's a thanks, Bobby. Okay, I think we'll stop there. But if anybody has any questions for Bobby, just send a chat message through and just let me know it's a question for Bobby, and maybe I'll get a chance to ask him at the end if there's any time. Okay, so let's move on. It's over to Francis.
Okay.
Thank you, Bobby.
Right, I'll just share my screen and take over. Right, what I wanted to do in most of this talk was actually demonstrate an application within MuleSoft and show how I'm going to make changes to it to suit API-led design. So first things first, I'm Francis Edwards. I'm an integration analyst and developer. I create MuleSoft APIs and applications, deploying and supporting them on our on-premise and cloud environments. I work for Saint-Gobain. I've been there current 4 years now. It's the building materials and retail and wholesale arm of Saint-Gobain in the UK. So it's selling all your bricks, insulation, plasterboard, those sorts of things. Out of work, I enjoy playing rugby and swimming, but obviously not a lot of that. So I'm just perfecting my MuleSoft usage. So the agenda that I've got is to show you a simple workflow that's not API led, and then demonstrate how it can be decomposed into the 3 layers that were shown earlier. Then with each of these 3 APIs, not just decompose them, but how can you make them more RESTful and thus reusable? And then I'll outline the coding considerations that are required for each of these 3 layers and highlight the benefits of designing the APIs in this manner. And then at the end, I'll take a few questions. Right, what's a point-to-point integration then? And particularly what makes them brittle? Well, many simple application flows mix and match mule scopes. So they can mix things like batch scopes. They can mix things like the orchestration, the process layers, and the choice routers. They can mix things like connectors to different things. Each of these different components within MuleSoft take up resource. You can end up with a large app that doesn't become a microservice. You can end up with something that's using too many resources for a simple once-a-day task, such as the batch scope. Filtering of streams could involve reading the entire payload into memory. So again, you may be using a lot more resource or a larger vCore just to hold an application in an available state. With the point-to-point integration, unit and testing and functional testing usually end up being the same thing. It tends to be a black box. You can put inputs in the front and you measure the functionality at the end. There's not a lot of ways of unit testing or breaking down the flows. And the processing is usually one way. So picking up data one side and putting out to the other with little scope for post-processing. So how do you check that your data's in the destination system without actually going to the destination system itself? Iterations to this functionality usually involve adding complexity. So if you want to send it to new systems, new choice routers, if you want to change the system it's pointing at, again, different sorts of transforms, you're almost rewriting the whole application. And the application itself usually contains a number of referenced libraries. So it can end up being a large deployable archive, and I'll demonstrate that. So a little diagram there, I'm just showing that it's principally a process integration. There's no experience or system layer to the integration. All right, I'm going to demonstrate this implication. Some of you might recognize the flows that are set up here if anyone's done the advanced training course with MuleSoft. This shows a simple file pickup, processing of that file, splitting it into a number of records, and then taking over with a flow that is capable of having more processes, more threads, doing some activity before going and submitting to the final system. So I'll just explain all the points that are going on here, because it'll soon become evident that the way I've named these flows, that you can see 3 layers within this flow. Initially, a file is picked up, a payload filter may be applied. This payload filter may just shrink the input to the input that's required. A transformer just to turn it to a string, and then a splitter, well, a string to collection, just so that the collection can then be split and fed into an internal VM queue. That can quickly then provide lots of messages that can be processed in parallel. A simple get to Salesforce may get you a response to find out if it exists in Salesforce or not, and then using filters, if it does exist, you can send it to an update, prepare the payload and just update the fields that you're allowed to update. Or if it is generally not in Salesforce, an insert and send it to a different flow that prepares the payload in a different way and then does an insert. I've got Salesforce composite connectors here because they're a useful way of doing a transaction scope within sending data to Salesforce. It allows you to update multiple objects at the same time for each of the different scenarios. And then at the end, just sending a VM result saying that all the messages are done back into the reply. Collect that up and send a response to the end user just to say the job's been completed. You don't know that it's in Salesforce. It could still fail in these 2 layers. This response is simply saying that you've sent the big file, it's been processed. So how can we break this down? Well, looking at the first flow, that is, in its essence, is an experience layer. Although I've named it process, you're taking an input, doing some sort of activity to it. It could be that you only do this once a day, but some of the processing is quite heavy. So the payload filter, for example, might need to stream a large file, filter versus inputs from another file, or based on inputs from another API call. So this process, it's not used that much. It's probably got one thread, but it probably uses a vCore, a whole vCore in itself. And that in itself says that the whole app would have to use a whole vCore. This second layer, the orchestration layer, I'm doing a get against the Salesforce end object just to be able to find out, does it exist, and then choose to route to the actual flows that do the work. And the flows that do the work, they very much mimic a system layer. If we were to look at this application, you'd see that it doesn't really follow a microservice. It's 38 megabytes big. This app would take a while to deploy and upload to Cloud Hub. It will take a while to unpack itself, basically because it has a lot of connectors within it. So how can we break this application down? Well, I've created 3 applications, and I've taken these very same flows and just moved them into the other applications. So with the experience layer, you'll recognize the first flow, still the same pickup, still the same processing, the message queue, but this time, rather than using message queue, an internal VM, we're using a anypoint message queue. The capacity and the availability of that, plus the reliability of getting the message to the end, are better than the internal VMs. Then you consume them, again, with parallel threading, and send them to a HTTP requester. You could choose to send them to simply to a queue and then for the process layer to pick them up, but by going by HTTP requester, it allows the process layer to do some work on your behalf and to make the process layer more restful and reusable. If we look at the process layer, I've got a HTTP listener that's going to listen for the input. And crucially, it's got an API kit router behind it. This API kit router can use some RAML that you can define, just saying, what should that payload look like? So I've described very simply what the payload will be, the key index fields, plus a load of other fields in a alpha character format. That ensures that only the right data gets into the queue. If your experience layer had data that shouldn't be processed, it would be rejected by the API kit router, and the result would be sent up to the experience layer. That protects this process layer and allows it to be used by other experience layers, or allows you to not have to have so much error handling. So that's the reason why I don't write straight into a queue and take from a queue. I have a HTTP requester in front of it, which then feeds the queue, and the queue is then consumed by the process layer. The process layer does the same sort of thing. It does a get against Salesforce, and then some filtering or redirection to go into the update and insert flows. But rather than speaking directly to Salesforce, these then just simply go to outbound HTTP requesters. Crucially though, I've added the get into here. So this process layer, looking at the RAML, now provides you an ability to post, but also an ability to get. And that itself could then allow the experience layer to add further functionality to look to see, has the data been processed? Have I produced the assets that are required, either updating or inserting them? The crucial thing to note about these two layers that have been added is the size of them. If you were to look at the size of the experience layer, it's a mere 1.7 meg. So a microservice in essence. Very quick and easy to deploy, very quick and easy to update. Now that you're in separate layers, different developers could be working on the experience layer, putting in error handling, putting in messaging, defining the RAML contract, for example. The same with the process layer. The process layer is a similar sort of size, 1.7 meg. Again, very quick and easy to update, change, add functionality. And then finally, looking at the system layer. The system layer is taking the same way as the process layer, its input via our HTTP requester. It's using the same sort of API kit router with RAML against it to ensure that the payload is the right sort that's required for the different methods. And notice how I've split up the methods now. I've got a put option, a post option, and a get option. So that API kit router can basically take those two different types of payloads and keep them in separate flows, and so that they don't interfere with each other. Then the update flows and the insert flows themselves can prepare the payloads in each of the specific ways that are required for an update or insert. You can log the outcome, but then also you can send back a response to the layer above, which can then be collated, interpreted, fed back to the user. But that allows this layer to be a lot more usable. By taking the Salesforce query out of the processing and putting it into the system layer, this is the actual meat and bones of the whole application stack. So just going back to my slides, this is really what I wanted to show you. I've split that one app now into 3 layers. The 3 layers are decomposed using the endpoint queues, but protected using the HTTP listeners and the RAML contractor that defines what goes in. I've also loosened the process layer in terms of its contract to enable future functionality. And with the system layer, that's where I've really put the meat and bones of the RESTful functionality, because system layers become more reusable the more RESTful they are. Layers above proxy some of the functionality, or they use a subset of the functionality. If you want to get real good reuse, you really want to be concentrating on making your system layers as RESTful as possible. The example of this process layer, how do I make it more reusable? How do I reduce coding? In our previous conversation, we talked about having 3 applications. Yes, that could have 3 different developers, but you don't want to be doing 3 bits of work, because that's could be 3 sprints with the same person, or 3 resources being used. Ideally, you want to keep the experience as minimal change as possible. And the process layer, you don't want to change every single time you add some functionality. So this is just an example of what sort of functionality could happen. You could have a 1.1 version of your CRM. For example, somebody could say, let's index another field within our object. And that indexed field then becomes a query parameter for the process layer. Your CRM version 2 might have similar fields, but different fields. So how do you make the process layer reusable and without having to add in extra coding or extra choice routers or extra HTTP requests as query parameters? And that's what I'm going to show you next. If we go back to the process layer and have a look at the contract that I've written for it, we can see that I've put in not just how the query parameters can be used, but how they're used as a query string. So when you're defining a contract, you can say with a get, give me a list of query parameters, but that locks it to a certain system layer. So to unlock it from the system layer, to make it not specific to any particular system layer, you can just go for your key fields, but send them down to the lower level in the form of a query string. Query string would look something like that. It's just a JSON object with a list of key pairs, which are the query parameters themselves. And that allows you to add extra things. So say, for example, you add a pagination functionality. You might want to have it as a possible query parameter, but also you might want to be able to just go to page 1 when you make a call against this. So I've said that you can have any sort of query parameter here. I've not locked it down to certain ones. I've also said that the object could bring back extra data. So this allows this process layer to not just support the existing system layer, but any adaptations to that system layer and possible changes to other system layers. In code, this query string looks like which one's get? Instead of using the query parameters and listing every single key pair, you list it as query params and just add in my case, a flow variable, which has all the query params. That allows me to manipulate those query parameters before I do a call, depending on which experience layer is calling which system layer. So essentially what I'm doing is not tying this functionality to any one system layer. So not forcing these three apps to be upgraded or changed in concert. So in summary, to be API-led, each API needs to be managed independently. And to do that, you really do need things like RAML contracts. HTTP listeners can be used to receive these payloads and assure RESTful interaction. Just by having a listener and API contract, you've automatically given yourself extra error handling. If you describe the API in RAML, you're protecting your underlying process layer and insisting on a certain type of payload being put into each of the different methods. It also allows you to, as I said, to use the default handling. Oops. By using endpoint MQs, you just get reliability and performance into the API. And if you use your query parameters as JSON objects, you're not tying your process layer anywhere. If you make system layers as RESTful as possible, transforming responses and resources where required, that allows you to create new methods. You'll notice I didn't have the put method originally in the original integration, but because I had the two different flows for the put, the upsert and the update and the insert, I was able to expose that update as a put method at a future stage. And then another important thing is to add the auto-discoverable global configuration into each of the APIs, because this allows you then to drag and drop different policies within each of the API layers. And depending on what you're trying to do, you might want to be throttling your system layer, you might want to be protecting your experience layer, and you might want to be protecting against injection attacks and making sure the process layers can only be used by certain experience layers. That allows you flexibility to size your APIs and size your applications, more importantly, to exactly the vCores that you require. So in the examples that I'm showing, the process layer could be a 0.1 vCore. The experience layer could be a full vCore, but only for a certain amount of time during the day, and use a cron to switch it on and off just to give you a window of being able to upload. And the system layer is the meat and bones, justifying its whole vCore use. But you're adding extra functionality, which allows you to give greater scope for future use of the data within it. So that's what I was going to show. So has anyone got any questions or comments?
So questions just come through. Francis, will the API spec stroke RAML remain the same for decomposed 3 layers, or are there differences?
No, in my example, I've made them different. I've got a system layer and a process layer. So for my system layer, I'm not simply proxying. I think the question is really geared at, are you just proxying the lowest level RAML up through the stack? No, not at all. My system layer includes a put, a post, and a get. My process layer only has the post and the get. My process layer has the regex to describe what fields are being used to loosen the contract, but the system layer can be developed separately, and you can start putting in fields that are specific and describe your types so that you can really nail down what's required. You can have things like telephone fields that require only numeric entry, and then a regex to support that, and that allows you to protect and specify exactly what sort of data type you require in the system layer, whilst not tying it to your process layer.
Thanks, Francis. Okay, next one is, do you find that the layering approach proves difficult in some cases?
Yes, it can do, particularly when you go for bidirectional flows. And that's really where I've got my message queues coming in, because with bidirectional flows, you're likely to have 2 separate system layers, one for one CRM system, one for possibly another enterprise system. And then you use your process layer to orchestrate the data between the 2. That might be kicked off by a call from the experience layer saying, here's a timestamp when one system is the master and the other system's not the master, or here's a timestamp for when the other system is the master. And that gives you an idea of making calls against the data and deciding which is going to be the master.
Okay, thank you. A couple more here, Francis. what was the advantage of the queues within the system layer?
The queues are really just there to manage the flows. What you didn't notice in some of these flows is that I've put high throughputs on a lot of them. So any flows that are outbound, I tend to have error handling in. Any flows that don't need error handling, such as the gets, because they're just setting variables, don't need error handling. But if you look at things like posts, it's likely that the calls to the underlying system are going to be a bit slower. So you might want to throttle or have more threads available. And that's really why I have the queues, because it's a way of reliably picking up the data coming into the API, but then having it in queues to be consumed at the pace or the throttle speed that's required for the underlying system layers.
Okay, thank you. And I'll read this one out. How do we implement atomic transactions in API-led architecture? For example, I'll read the whole thing out for everybody. For example, I have a system API which is connecting to a university DB. I want to make SQL executes on two different resources. One, an update in student table, and two, update student score in report table. How to make sure the student table is not updated if the update in report table fails? Sounds like a transactional question.
That sounds like a question for a solution architect, but there's a whole section on things like the Salesforce update connectors. You can, if you're doing an ACID or an Atom update to a database, you really want to be having transactional scopes so that you can roll back a transaction if you don't complete part of it. And that's what this Salesforce composite object does. It's a similar sort of thing. It takes in the input data, chooses which objects it's going to update. If it doesn't update all the objects, it'll roll it back. If it does update it, it can commit it. So hidden within the functionality of a Salesforce composite connector are a series of gets to make sure the data will pass validation, will pass entering into the system, and then it'll only commit to the system if everything is good to go. With a database, you're describing a similar sort of thing. You would have a transaction scope with a number of upserts, updates, inserts, merges, whatever database queries you need to apply, but you'd need to be able to roll them back if one of the set didn't work.
Okay.
Want me to chuck in to NP as well then, Francis?
Please, Bobby. Yes.
Yeah. So again, you back to the functionality of what you're trying to do, arguably. So if you're updating a student score and for a report, you potentially, if it fails, you can rerun it another time. You can do it, as Francis said, in some sort of XA sort of transactions, and implement a commit statement at the end of it. There's potentially various ways to do it, depending on depending on the criticality of what you're trying to do, and if it goes wrong. So I'll shut up there because I'll go on forever from Terry.
Don't worry. Okay, just the last one then before we move on, Francis. If we're splitting up those applications like those three instead of one, what is the processing time difference?
Well, that's the reason why I'm using things like the API kit routers. The error handling on the API kit routers can be measured in microseconds. It's incredibly fast. The flows that I described there, because they're not doing any filtering, because they're not any data transforms, they're simply enriching data, then you'll be lucky if they add 60 to 100 milliseconds onto a call. It's the system layer where most of the real work and time is going to occur.
Okay, I hope that answers Rakesh. Okay, thanks, Francis. I think we're probably going to have some time at the end, so if there's any more questions for Francis, we'll keep those to the end. I've got a couple in for Bobby here already as well for later. Let's go over to Justine now, I think.
Okay, can you hear me well?
Yes, absolutely.
Okay, very good. Okay, so just let me know when you can see the slides.
Yep.
Okay, very good. Okay, so hi everyone. Thank you very much for joining. I'm Justin. I'm a technical architect at Trixton, who was very recently acquired by Global SI, EPAM. I've been working with Thermota for I think it's 3 to 4 years now. And in this presentation, I'll be going through some of the successes we've had, some of the challenges we face on a day-to-day basis, as well as how we got here. So just to give you a brief summary, Air Malta is a small company in a small island. Because of Air Malta's business environment, cost efficiency is a priority, especially nowadays with COVID-19. Not many planes are flying. Being in a highly competitive market with players much larger than Air Malta competing in the same space, it's very hard for Air Malta to benefit from economies of scale that you might find with other more larger airlines. For example, another larger airline, for example, Ryanair, might get more value out of the same software license as Air Malta. However, the cost there is effectively the same, regardless of whether you are a large airline or a small airline. So we have to be somewhat more selective about our integration choices there. There's a strong dependency on legacy systems, not only internally, but also with external partners as well. Many of Air Malta systems have been around for quite a long time now, but that is slowly starting to change with the introduction of several APIs and capabilities we introduced in the last few years. Similar to most airlines, Air Malta tends to use off-the-shelf products and therefore depend on the capabilities and timelines of their vendors, which somewhat contributes to the issue of slow change. Most integrations were developed in a point-to-point fashion, which resulted in isolated and monolithic solutions. This might be because the team responsible in maintaining these systems has changed. Some people might have actually retired, or people are just unwilling to change things simply because of the serious implications if things were to break. As you all probably know, splitting such integrations is oftentimes a large effort in and of itself. So API-led connectivity kind of resonated with Air Malta as a solution for their state at the time. So Air Malta decided it was time to see IT from a different angle, not only as the backbone of the company, but one which transitions from a cost center to a profit center. And this effectively led to a shift in focus and opening up new revenue streams, being a center for innovation and one which operates very efficiently, became a topmost priority for the airline. The goal was to launch new products quickly, adapt new and existing products to customer needs based on feedback from customers themselves or from other departments within the company. We wanted to improve employee experiences via automation or at least facilitation of their day-to-day tasks, and as a result, positively influence daily operations to make them more efficient. Now, starting off, we established a core set of principles that would guide Air Malta through their digital transformation journey. I mean, some of the key decisions were to introduce new tools to support the change, create new opportunities for the business in terms of facilitation of existing business processes, or, as I said, the introduction of new revenue streams, shifting to a new and automated delivery model, gaining experience through iteration, and most importantly, become as vendor agnostic as possible. And this is what 2017 looked like for Air Malta. Air Malta was standing very much on the edge, with simply observing third parties doing the heavy lifting. There was very little visibility on what went on under the hood, and every change meant that a vendor had to be involved. This resulted in several point-to-point integrations, and then in general, slow turnaround time due to having such a strong dependency on the vendor's availability and also their capability as well. With the introduction of the Anypoint platform, Malta started gaining more control, and they began to coordinate the data flow between all of these systems that you see here. Most of these were actually unlocked by a series of system, process, and experience APIs, which abstracted away most of the nuances and intricacies of each system, thereby allowing new integrations to be realized much more quickly. So the initial team was formed by establishing an Air Malta platform architect with clear executive sponsorship from Air Malta's CIO. On the other hand, Rixton formed a development team of MuleSoft consultants to build out Air Malta's hybrid integration platform, spanning across several environments in both cloud as well as on-premise. Now, this also included tools that were required for development, testing, consistent deployments, and monitoring, such as CI/CD servers, artifact repositories, infrastructure management tools, Git repositories, so on and so forth. One of the initial mantras that we started off with was that lessons are learned through iteration. We are constantly looking to improve our standards on a sprint-by-sprint basis, taking in feedback from pretty much from the rest of the business and departments that we work with to develop our integrations. Now, a topic which was addressed very early on in the project was the issue of having consistent deliveries and a consistent application deployment pipeline. The idea was that the less human involvement there is in deploying an application or an API, the easier it would be to push features and fixes out faster. As a result, the risk of human error is always kept to a minimum, and therefore there is a certain consistency to the deployment methodology. To achieve this, we utilize Jenkins, an encrypted vault for application configuration and password management, Ansible for infrastructure configuration, and a couple of other tools. Any application or API deployed through the integration platform is monitored and managed by several tools, such as log aggregation and alerting software, API monitoring and server monitoring built already into the Anypoint platform. It comes out of the box. And we typically use these to detect unexpected spikes in HTTP traffic or an uptick in error rates, for example. And we also make use of several other infrastructure monitoring tools, which were built and installed in collaboration with Air Malta's infrastructure team. Now, one of the challenges we faced initially, and honestly still face nowadays, is the lack of a dedicated QA team. Some companies have the luxury of having a development team who typically perform unit tests with a small set of integration tests, and a dedicated testing team who perform a series of end-to-end tests, functional, possibly even manual tests, so on, to kind of ascertain a certain level of quality that is expected by the stakeholders. Unfortunately, this is not the case for us. We're still a small team, so having a series of automated tests to ensure our applications still work, even across upgrades, was and still is, in fact, a must. In fact, no feature or fix, for that matter, is complete without an accompanying set of unit and integration tests. This might make our development lifecycle somewhat slower, but as a team, we believe that a test harness is an investment worth spending time on. That's just how we feel about it. Some clients feel differently about it, but that's just something that we've stuck by, and it has paid off a number of times throughout the years. Now, the automation part was addressed by a CI/CD pipeline, which runs our tests before and after a feature is merged into the main code base. The same CI/CD pipeline, which, as you can see here on your screen, is Jenkins, is then used to deploy our applications to various deployment environments, either in the cloud or on Air Malta's on-premise Mule cluster. Now, once you actually ship a product, then there's the issue of actually maintaining it in production. As mentioned earlier, we're still a small team, but we have various strategies which together allow us to maintain our integrations. Our log monitors and alerts all play a very crucial role in helping us to support this architecture, since they actually allow us to report and fix issues before the rest of the business teams are aware. Being proactive and one step ahead of the business is something which we always try to stick to, and most times it has paid off. I mean, nowadays, Air Malta's IT team is regarded within the company as one which is able to solve problems quickly and efficiently, partly owing to the visibility which our tools give us. I mean, this is not something that would have been possible prior to 2017, for sure. So our day looks like this. We start off the day by our morning stand-up routine. For those of you who are unaware, a stand-up is where you say what you worked on the previous day, what you plan to work on that day, and whether there is anything impeding you in achieving, your daily tasks. We try to stick to our sprint goals and tasks, although being a small team, it's sometimes very hard to get away from a series of meetings at times. I'm sure most of you can relate to this. And we work across various parallel deliveries across many verticals within the airline. So flight operations, finance, reservation system integrations, and so on. Deployments are pushed out whenever features are UAT'd by Air Malta, with no necessary coordination with other departments or other teams, owing to the reliable one-click deployment methodology, which I explained earlier. Tests and documentation are also an expected outcome from any work that is developed and agreed to be developed during the sprint. So 3 to 4 years of development and architecture has led us to this diagram, albeit this is somewhat of a simplified view. Prior to 2017, this would have been several lines scattered across each other. But with the introduction of API-led connectivity, each API abstracts away from the nuances of the systems beneath it. Any integration nowadays goes through an existing API or a new API built specifically for that integration at the appropriate layer. And this follows one of the mantras which I mentioned earlier about Air Malta being in complete control of their data and their processes. I should mention at this point that the boxes you see on screen under each layer weren't affixed to their respective layer immediately. We let each API evolve, and over time it kind of became obvious under which layer it fell in. I mean, I've seen clients specifically design APIs around their layers, which at times has resulted in a ballooning application count, which in my opinion is somewhat self-defeating, because you're just adding more and more applications to maintain and thereby slowing you down. We took a different approach. We tried to value functionality and abstraction over the layer of the API. We just found that the right layer just made itself known purely by virtue of the API's functionality. So how did we achieve this? One of the major use cases which kickstarted Air Malta's move to independence was the creation of several system and process APIs layered on Air Malta's reservation system. So using these APIs, Air Malta was able to retire several systems which at the time were considered black boxes, and these were instead replaced with new ones which were more documented, they were well understood, and they were tailored to what Air Malta specifically needed at the time. These APIs currently serve as the backbone for many back office applications which are used by Air Malta on a day-to-day basis. They are also used by third-party integrators who are nowadays able to sell seats on Air Malta flights via their own websites. And basically, the successful completion of this scenario or of this use case meant that Air Malta could tailor a booking workflow specific to each integrator, as opposed to relaying one which was pre-built by a solutions provider. Now, the second use case actually builds on top of the functionality established in the previous use case, in use case 1. Brand identification was used to help check-in desk agents clearly identify the class of service, or otherwise known as a brand, of a passenger's ticket. In doing so, desk agents are much more efficient in, first of all, checking a passenger's luggage at the desk, and also checking their allowances, since their class of service is now actually imprinted on the passenger's ticket. Before, what used to happen was that the desk agent would have to pull up the information of a passenger and making sure that their luggage that they have with them at the airport is adhering to what they actually purchased on the Air Malta website. Now, given that the check-in agent doesn't have to go through several steps to make this check, instead it's imprinted on the ticket itself, this has led to a more seamless passenger journey and a more efficient check-in process in general from the desk agent's perspective. Now, the third use case was of significant importance to Air Malta because it deals with the very heart of their flight operations, that being crew roster management, who is going to operate a flight. Now, Air Malta wanted to introduce a new rostering system that would alleviate a number of pain points of their previous system. For example, automatic rostering based on crew leave requests and strict adherence to EU legalities, and a fair and even assignment of roles across crew members. This use case really brought home the reusability aspect of the APIs that we built over the years, in that most integrations which served the previous rostering system were simply moved over or pivoted, you could say, to integrate with the new system instead. Given that we had built this anti-corruption layer, you could say, existing integrations did not break, and Air Malta were in complete control of when the switch from the old system to the new system would happen. Something worth mentioning as well is that we could also support a phased transitionary period between the old system and the new system. We avoided a big bang approach where things might not have worked due to some unforeseen scenarios, which would have resulted in a rollback headache. So I think all in all, our work thus far can be summed up in 3 short metrics. So the first one being that Air Malta is in complete control of their business workflows, and any customization requests are handled in-house. I mean, this has greatly reduced the time needed to deliver features and fixes, owing to the lessened reliance on other providers. Having a one-click deployment capability has also proven its use time and time again, since the DevOps team is not bogged down by manual system and application configuration. There's also the aspect of not having to coordinate deployments with other departments within the airline, leading to faster and more seamless deliveries. And thirdly, our APIs are always built with reuse in mind and actually contain very little custom code. Our APIs are developed using the MuleSoft's pre-built components, most of which you will find in Anypoint Studio. And as a result, this has led to a faster and more consistent API development lifecycle throughout the years. And I think that's the end of my presentation. Thank you very much, everyone. I think I'll take questions now.
Thanks, Justy. Any questions? Okay, while we're just thinking if there's any questions there, I'm just going to ping back to a couple of questions I missed earlier. Yeah, there is a question now. There we go. Justin, how did you structure your teams?
So there was me playing architect and developer at the very start, but then I kind of transitioned into an architectural role. We're only a team of 5, so we're pretty much developer, tester, operations all in one go. So it's a very flat structure. I just happen to work more with Malta's team purely by chance. I mean, the rest of the team, there's developers and testers, you could say.
Okay. And how fast was the deployment using the CI/CD pipeline?
So I think it depends on the API. Some deployments take seconds, some take minutes. It depends what are the touch points of the CI/CD pipeline. So if we're deploying on premise, there might be touch points on load balancers, firewalls, the endpoint platform for sure. We use the endpoint platform APIs to deploy our applications. That's on premise. When you have deployments on Cloud Hub, they might take a few minutes, but that's purely because of Cloud Hub's zero downtime deployment methodology. It takes some time for the load balancer to shift requests from your old deployment to your new deployment. Hope that answers your question. Are there any more?
I'm not sure if we have Terry. Is it just me or I can't hear him?
I think you're on mute, Terry.
I'm on mute.
Okay.
That's deliberate, actually. Thank you for saying that. How is your testing strategy? Automating testing experience would have duplicate the testing of process and system APIs. I'm not quite sure what that means, but maybe you do.
No, we do not duplicate tests. So we treat APIs as kind of black box pieces of functionality. So if we just test the boundaries of an API, we don't actually test the functionality of an API that we are integrating with, because that's something we believe in that's something that should be tested by the API itself, not by the API, not by applications who are calling the API. So if we're talking about normal HTTP APIs, we make use of mocking servers. I know WireMock is quite famous, and we've had a lot of success with WireMock, where we would just simulate a series of requests and responses as if we're sending requests to the actual API. Mule would have no idea that there's a mock server sitting on the other end instead of the actual API, and we just make sure that the application works as we would expect if we had to receive a response that might either be a success or a failure.
Thank you. I'm going to come back into the general question. How was the integration testing integrated into CI/CD pipeline?
Sorry, can you repeat that?
Yes. How was the integration testing integrated into the CI/CD pipeline?
Right. Okay. So it's quite technical. So we use Maven Surefire plugin for our unit tests and Maven Failsafe plugin for our integration tests. So most of our unit tests, unit tests, sorry, I should say, is handled in the Maven test phase. And most of our integration tests are done in the integration test phase of Maven. Our CI/CD pipeline just goes through the Maven lifecycle until you hit the deploy phase, at which point it's sent to our application repository. So, I mean, some things you might find in our integration test phase is the spinning up of Docker containers specifically for that integration test run. We might spin up wire mock instances. We might have load tests on Cloud Hub, for example. It all depends on what the API is or what the application requires. We just find it useful to be at the integration test phase because it allows us to ensure that the APIs or the integration's functionality actually works as expected before it even hits Air Malta's development environment. This is kind of how we gauge quality in our deliveries effectively.
Thanks, Justin. There's one more specifically to you before I open this up a bit. You mentioned it took 8 weeks to finish the Malta flight apps. What was the most challenging in terms of figuring out or thinking process, I think here, the data transformations, security, or converting legacy apps?
I think it was mostly trying to find the gaps between the old system and the new system. Data formats were all custom, so you wouldn't have we didn't have common data formats like comma separated files or tab separated files or JSON or XML. It was very airline specific. Thankfully, we didn't have to deal with ACARs for those of you who are more airline savvy. And the multitude of integration protocols that were needed for this integration to be realized. It was messaging, HTTP. At times, a service might require a file drop every once in a while. We try to abstract all of this away behind different APIs. I think in hindsight, we've kind of succeeded. If I had to go back and change some things, I think I would. But overall, it has proven to be quite a stable architecture, even though we finished it in 8 weeks as opposed to, I don't know, however long it was expected to take.
Thanks, Justin. I'm just going to give you one more. Do you use attached libraries, such as for login or error handling, to speed up development?
So when it comes to logging, yes, we've built an Air Malta logger connector. And this is something we use in every one of our applications, and it is something which our log aggregation tool expects. In fact, it was built specifically with log aggregation in mind. And there was something else other than logging. What did you say, Terry? Sorry? Logging and error handling, right?
Yes, it was.
Error handling. Yes, there is a Mule library, but we haven't actually built one for Mule 4. At Air Malta, we try not to over-optimize and create libraries without seeing. Look, before we see use for it in at least 3 different applications or APIs, we do not put things in libraries. As soon as we start seeing common patterns, that's when we start considering, putting things into libraries. Error handling and logging being one of them. Some of them, at least.
Great, thank you there. Just trying to find the question that I was going to ask to everybody. Okay, this is a question, Justin, you can answer by all means, but Bobby, Francis, please give your view as well. What tool do you use for automated integration testing?
So do you want me? So I'll go first then. So what we're currently using, our tool of choice within the bank is GitLab. We're using GitLab as the let's call it the pipeline development tool. So that deploys the code into the various environments for testing. What comes with it is a SAST test, a DAST test application, and Germanium, which you think is to do with your links and all this sort. So if you're asking what DAST and SAST is, it's something like security architecture system test. So I can't remember. Oh no, the first S is static application security testing, because the D on the DAST is dynamic. So they're doing specific types of integration testing. We also use there's 2 applications. There's a Citrus. We started using Citrus to do sort of end-to-end API testing. That was done on the onboarding project that I talked about. I subsequently found out it wasn't properly integrated into GitLab scripts. I subsequently found out it couldn't necessarily easily be done that, because the GitLab scripts were looking to deploy applications, and this required the whole application estate to be available. I then found out literally last week there was a team in the bank using Karate to do end-to-end testing of APIs. And again, I'm now touching base with them to find out more about what they do, what level of things to governance of them. So that's where we're at the moment. I would add as well, and Justin, it's probably worth you commenting because you've had more practical experience in this. It's not quick and simple and easy. So it's still evolving as a process for us at the bank.
No, and something which I found over the years is that there isn't one solution that fits everybody. Especially when you talk about deployments, each company has their own security requirements, infrastructure. So it's very much something that you have to tailor for each customer, I think. You mentioned something about
testing tools.
Sorry?
Testing tools.
Yes. So Karate and Citrus is something that we did take a look at, but again, since we're a small team, we have to very carefully select what new technologies we onboard, because we just cannot be stretched too far. When it comes to deployments, we try to be as vendor agnostic as possible. At the moment, we use Jenkins because that's what most of the team was comfortable with at the time. We have considered Bitbucket pipelines and something like GitLab, and probably the transition wouldn't be that difficult. But it's something where you have to start and finish, I feel, at least relatively quickly, because you just cannot have one foot there and one foot here. Otherwise, you're just adding more and more things to maintain. That's counterproductive, in my opinion.
I echo what they said about it. It's what the team's familiar with, and certainly with our team,
definitely.
I try and enforce coding convention to give the option of M-unit testing. You noticed in the app that I showed, the flows are quite simple: known message in, known message out. That encourages the unit testing of each of the flows for individual bits of functionality. But then for end-to-end testing, Postman, and with load testing, using the collections within Newman.
Just the other thing, just to shout out, Balachandra has mentioned the fact that they use Postman for testing. So the interesting thing, when I when I touched base with this team, so they were they're not part of the delivery or development group, they're part of the test team. And arguably, testing, end-to-end integration testing should sit within the test team. Therefore, it doesn't surprise me they've got their own sort of service to deliver that. But it's a good point that they said they used Cratty for something, but they found it overcomplicated for some basic sort of API end-to-end testing. And therefore, they did use a lot of Postman sort of scripts too. I'll finish, by the way. Anyone else can talk?
I think you're on mute, Terry.
Yeah.
Just before Yeva reminds me about the photo, I think we ought to go to the photo now because I know she's really keen on getting a photograph of everybody that's still online. Yeva, is it easy to do?
Yeah, just give me 1 minute. I'm slowly making everyone a presenter, so you guys can choose if you would like to open the cameras or even open the mics right now, as we are more into networking part, e-networking part. So going through the list. Also, I'm very keen to see if we actually have dogs on this meetup.
We didn't get any questions from dogs, did we? No. Got a mule though, Yeva. Oh, and another one. And a MuleSoft mug.
Oh. Well, apparently, all brand new in the EMEA these days. You can get MuleSoft cap.
Yes.
The old one.
Yeah, very good. I mean, very impressive. Kevin, yes.
Almost. Few more people.
Justin, I mean, like your solution seems to be really interesting, to be frank.
Thank you. There's Angel. Hi, Angel.
Hi, Terry. Hi, everyone.
Good to see you.
Yeah, it's been a long time, eh?
Yeah, it has.
And here we are. All right.
Hi, David. There's one more. Oh.
I hope I haven't forgot anyone. Does anyone have a right to open the camera? If not, please shout or write. Yeah, I think all right. So yeah, let me take a picture. Is everyone ready?
Yep.
Or we look good? All right, let's see Mule. 3, 2, 1. All right.
Okay.
Perfect.
Perfect. Are you going to send that round to everybody? Yeah.
Definitely.
Perfect. Okay. Are you choosing the 3 people after this event, Yeva? Yeah.
Yeah.
We'll do that later.
Or
yeah?
I can actually
now.
share my screen right now for a second, and we can
That's a good
see
idea.
who won. Let me do that. Can you see it?
No. Yes. Oh.
Wow.
Infinity.
And now is it better?
Yep.
Okay. So I've tried, I hope I've put all the names to the list. And we have a number of 3 vouchers that you can guys use for a MuleSoft course of your choice. And let's go. So these are the winners: Lee, Parameshwara, and Stuart. Congrats.
Well done. Great. Thank you. Okay, I think that's drawn the evening to a close. Fantastic night. 3 really interesting presentations. I hope you've all enjoyed it, and it's just really great to see so many of you here. And I'm just going to quickly recap what I said at the start. What makes this successful is all of you that are on the other end of the line. And what we really would like to kind of get you to think about is any of you can present at these sessions. We would really love to see more people present. It's great to get your ideas over, debate them with the group, because this is the group that, you know, knows the product, uses it every day. Everybody has a slightly different view, so debate is really, really good. So if any of you want to attend the next one as a speaker, please get in touch with Yeva. That would be fantastic. So till next time, I personally would like to thank all the speakers for a fantastic session. That was really good.